Yes, friends, now our Kubernetes cluster that we created is ready. Now, what's inside this cluster structure, what's not, and what are we going to do? It's also important for us to understand this a little bit, friends. Now, normally, a Kubernetes cluster creates a structure like this, and I mentioned that there are nodes inside it. Now look, friends, when you create a node here, inside this node, it has its own network. In other words, the cluster already has its own network. But here, the Kubernetes node has its own network. It has its own structure, its own hard disk, its own CPU. Now, what was our CPU here, friends? Actually, it's 2 CPUs, but it's referred to as 4 vCPUs, friends. It's called a virtual CPU, and here you also have 32 gigabytes of RAM. Now, this setup here gives us 4,000 units, or 4,000 millicores, of CPU power to use. We will need to create computers for the Docker images that will run inside the node within the structure of the cluster using this 4,000 millicores of CPU power and the 30 gigabytes of RAM here. Let me put it this way. A node is, yes, a virtualized PC. In other words, it's a PC that is virtually allocated to you in the cloud. Now, this concept here is important because the amount you rent here is allocated to you from the physical computers in Google's own data center. So, an area with 4 vCPUs and 32 gigabytes of RAM is allocated to you. That allocated area becomes your node, friends. Within this, you create pods like this. Pod. In these pods, friends, you are provided with the structures where you can run your Docker containers inside the nodes. So, you can run your Docker images inside these pods. This pod, friends, is a virtual computer. And just like you did with the node, you will configure this as well. Look, the node is a virtual computer allocated to you from Google's physical machines. Pods are virtual computers that you configure to use yourself within the node. In these, you set the CPU and memory yourself, friends. For example, you call it a CPU. What are you going to do with it? Config server. You say that 200 M of CPU power is enough for config server. You say RAM, 124 gigabytes of RAM is enough. Well, let's not say gigabyte, let's say megabyte. When it's 1024, it goes to megabytes. You say, for example, this amount of RAM is enough for me. You create these pods virtually according to your needs. Inside these, you can put and run the images you've uploaded to Docker Hub, friends. Images can be launched inside these pods. Think of it like this. Just like you launch containers in Docker Desktop, you can also launch containers on pods in the same way. But the general best practice here is this, and you should do it this way too. Only launch a single image in one pod, friends. So, don't do it like this. Don't just throw the auth service, the user profile, and MongoDB all into this pod. That's not how it works, guys. Or don't think of it like this either. You know how every microservice has its own database? Yes. Then let me assign both the microservice and its database to this pod. No guys, that's wrong too. Stand up one image in a pod. So you're going to uninstall PostgreSQL, one pod. MongoDB, one pod. Auth service, one pod. It would be best to do it this way. It works with a structure like this, friends. Alright. How do we connect to this thing? So how do we connect to this Kubernetes cluster? Look, over here in the Actions section, there's a connect option. Guys, you can come here and perform the connect operation. Now, connecting can be done in two ways. First, you install the kubectl tool on your own computer. Then, to connect to Google Cloud Container, you type the command here. To do this, you need Google connection configs and such. It's a bit of a lengthy process here, so you need to configure this. And, you need to know how to do this. This will tire you out a bit, guys. That's why I don't really recommend using this method. Instead, use the running Cloud shell here, guys. This lets you access your Kubernetes cluster directly from the browser and work there, which is super convenient, guys. You can access and edit your cluster from anywhere you want. Look, now it's going to paste this code itself onto the Cloud shell. You hit enter, and it asks you to authorize. You click authorize all. Now it's going to connect. Look, it's coming now. There you go. It's here. Guys, perfect. So now we've established the connection. But what are we going to do, sir? Guys, first, look here. You click open in a new window. You could just click open editor here directly, but I prefer working in a new tab. So I open the same connection again in a new tab like this. Now it's connected. Look, there's open editor right here. When you click this, look what pops up. You can close this now. You don't need this anymore since you've already connected. I'm closing it. Look, what's in front of you now, guys? What does this look like? Guys, this is basically Visual Studio Code as you know it. It gives you a screen where you can code directly with Visual Studio Code. Now, I'm going to go straight to the home directory here. Let me switch to my main directory. Here, I'm creating a new folder from here. Let's open it. I'm calling it Grow Services. We're going to work inside this. Guys, look, you can install extensions here. I've installed a few extensions here. Guys, just to make things easier for YAML, Simple Account, and Kubernetes. Other than that, you can choose the theme from here. If you want a dark theme, you can switch to any theme you like. I chose the dark theme and opened it like this. What else is there besides this? I recommend opening a terminal from here, because we'll be working in the terminal. We'll be working here. We'll also write our code here. Right now, if I type kubectl get pods, no parameters will show up. But when I type kubectl get nodes, you can see the node I'm currently working on here. Let's also take a look at its properties. I type kubectl tab nodes, and I can see the properties of my node here. Right now, we're using 92 megabytes of CPU, so that's 2%, and we're using 877 megabytes of space. That means I can see I'm using about 3% of memory. So at this point, my Cloud Shell is ready to work. So what are we going to do here now? Here, we'll need to write deployment objects and service objects that can run the images we've created and pushed to Docker Hub. Of course, you need to know a bit about Kubernetes here. So, what is a deployment object? You need to know what a Kubernetes object is, what Kubernetes objects are, and how to use them. I'll send you the configs for these here. They'll be available here, and I'll also be adding them to the training materials. Guys, you can take them from there, adapt them to your needs, and use them directly. I'll just tell you how you need to modify them. Guys,